Alright, welcome to 3.3 Graphs of Tangent Functions. So these are a little different than our other ones. So if you look at the graph right here, they're called as vertical asymptotes. And the tangent graph increases from left to right in between these two asymptotes. Okay, and then this graph right here is what I did on Desmos and just copy pasted it into there. So these points right here are what we'll plot. Okay, so we'll need 1, 2, 3, 4, 5 different pieces to that puzzle. Okay, so that's what we're going to be working on today. So our guidelines for sketching graphs of tangent functions. Okay, we're going to first find our period. Alright, and then that's going to help us find our adjacent vertical asymptotes. Okay, and the formula for our vertical asymptotes is here. So our left asymptote is bx equals negative pi over 2. Our right asymptote is pi over 2. Bx equals pi over 2. So this is my right my left vertical asymptote. This is my right vertical asymptote. Okay, abbreviations, they're lovely. Alright, so once we find them, we're going to sketch them. And then we're going to take those pieces and we're going to chop them in halves. Alright, we're going to create the 4 equal parts that we need. And then we're going to use our A value, okay, and treat it like slope to find the other 2 points on the graph. Then we're going to join everything together with a nice smooth curve. So for our first graph, we have y equals tangent of x. So step 1, so we're going to label our A and our B. So this is the format. Y equals A tangent B of x. So A equals 1, B equals 1. Alright. So then we'll find our period, which is pi over B. Plug in 1 for B, so pi over 1, which is just pi. So that's our period. Now we're going to find our vertical asymptotes. Okay. So our left vertical asymptote, bx equals negative pi over 2. And then my right vertical asymptote is bx equals positive pi over 2. So now we're going to substitute 1 in for b. So just get 1x equals negative pi over 2. And get x equals pi over 2. So to put the asymptotes onto the graph, you're going to start in your origin there. You're going to count 2 units to the right, draw your asymptote, and then go 2 units to the left, and you draw your asymptote. Alright, and then we'll label them. This is negative pi over 2. This is positive pi over 2. And then we're going to take these pieces and we're going to chop them in half. So step 2 we just did, that's graph the vertical asymptotes. Alright, so in words what we did, we start at the origin, and then we're going to go right 2 units, and then we go left 2 units. how we do that. So our next part, we're going to chop these into equal parts. I'm going to switch colors here. So step 3, chop into equal parts. So we're going to take each of our asymptotes and then divide by 2. We have negative pi over 2, and then instead of dividing by 2, you multiply by 1/2. That's going to give me negative pi over 4. And then on our right side, we're going to take pi over 2 times 1/2, and I'm going to get pi over 4. Now remember, dividing by 2 is the same as multiplying by 1/2. Okay, so these are our new points here, so I'm going to put them on the graph. So negative pi over 4 and pi over 4. You can put them up here in this area up there for on the tick marks, but for space reasons, I just put them down low. Alright, so we're going to plot our points. Let's start at the origin. Alright, because we don't have any shifts yet. I'm going to talk about that when we get to them. So start at the origin. Alright. So we're going to use the A like slope. Okay, so our A for this one is 1. So from the origin, I'm going to go up 1, right 1, and go down 1, left 1. And then step 5 is connect dots. Okay. So we're going to stop at the top, increasing from left to right. So bottom left and up. And this graph will repeat forever and ever and ever, to the left and to the right. That's your period, so nothing changes right there.
What does it mean to be a good neighbor?
It means being there for each other.
Okay, so example 1, I'll move on to example 2. So we're just going to change our values a little bit. Step 1, A equals 1, B equals 2. Our period is pi over B. Substitute 2 in, so we get pi over 2.
Not to be dramatic, but
Okay. Now we'll find our vertical asymptotes. So my left vertical asymptote, bx equals negative pi over 2. Right vertical asymptote, bx equals pi over 2. Alright, so my value of b is 2 here, so I'm going to substitute that in. Alright, so I'll have to divide by 2. Alright, we can't divide that, so what we have to do is flip the 2 and multiply by its reciprocal. So we'll get x equals negative pi over 2. Reciprocal of 2 is 1/2. So x is going to be negative pi over 4. Same thing on the right hand side. We have pi over 2 times 1/2. So x equals pi over 4. So these are my asymptotes. So again, we'll start in the middle, go right 1, 2. Draw my vertical asymptote, which will be pi over 4. And we'll come left 2. This will be negative pi over 4. So that was our step 2. So step 2 is the graph, done. Now we're going to move on to our chopping step. So step 3 is the chop. So let's chop these. So left vertical asymptote, negative pi over 4, multiply by 1/2. negative pi over 8. So I'll just put that in there, negative pi over 8. Right vertical asymptote, pi over 4, cut it in half, equals pi, positive pi over 8. Okay, then we'll start at our origin. Alright, so slope time. So my A is 1, so I'm going to go up 1, right 1. And then from the origin, down 1, left 1. Graphs increase from left to right. Make sure you get close to the asymptotes, but you don't actually touch them. And there we go. That is the graph of tangent to x. Alright, so if you were to actually do it on Decimos or something, you could see that it's a little more pushed together because the period's smaller. But scaling, I'm not worried about. I just want to, it's mainly the algebra behind all that. So 5, graph, done. Okay. Sample 3. A equals negative 3, B equals 1/2. So my period equals pi over B, which is pi over 1/2. Flip and multiplies becomes 2 pi. The work in here becomes pi over 1 times 2 over 1, which equals 2 pi. And that brings me right back to there. Alright, so the negative A here the negative means means the graph reflects. So instead of our graph, so a positive A means the graph does this. So a negative A means the graph will decrease from left to right. So that's the only difference right here. So our next part, we have to find our vertical asymptotes. So vertical asymptotes. So my left vertical asymptote. So we get bx equals negative pi over 2. Plug my b in, so I get 1/2 x equals negative pi over 2. Divide by 1/2 means I'm multiplying by the reciprocal. So flip and multiply. So x is going to equal negative pi. The right vertical asymptote, bx equals pi over 2. Substitute in 1/2 equals pi over 2. Flip and multiply the fraction to each side, so we get x equals pi. So let's start at the origin. Alright, and we go right 2. Draw my vertical asymptote. Label it at pi. I'm going to go left 2 from the origin. This gives me negative pi. So asymptotes are drawn. We don't have any shifts. There's no h and k's yet. So our next part is the chop. So step 1, step 2, graph. Step 3 is the chop. So I'm going to take my left vertical. Okay, which is negative pi. Multiply by 1/2. Gives me negative pi over 2. Right vertical asymptote is pi. Cut it in half. gives me pi over 2. So we'll have negative pi over 2, positive pi over 2. Okay, now step, not there yet, step 4 is the slope time. So from the origin, I'm going to go down 1, 2, 3, right 1. Then we'll flip it and go up 1, 2, 3, left 1. Connect, a nice smooth curve. Make sure it's curved, not a straight line. So it should have some sort of bend to it, even though it's already stretched out. So step 5, graph. All right, so we messed with the A's and the B's in the past couple problems. Now we're gonna have a shift change here. All right, so standard formatting, y equals a tangent x minus h plus k. All right, so this is my left or right. This is my up or down. So quick refresher, positive h moves left, negative h moves right, positive k moves up, negative k moves down. Okay, so h is opposite, k is always the same. Alright, so beginning steps are still the same. So step 1, a is 1, b is 1, h, there's nothing going on inside the parentheses, so that's 0, k is 2. Period. Still pi over b, so it's pi over 1, which is just pi. Let me do our vertical asymptotes. So left vertical asymptote, bx equals negative pi over 2. Sorry, the struggles of parenting and teaching. Plug my b in, so we x equals negative pi over 2. Right vertical asymptote, bx equals pi over 2. So plug b in, you get 1, so x equals pi over 2. Alright, so I'm going to put a point here at the origin. The point will move eventually. But to get the asymptotes, we're going to go 2 right. Draw vertical asymptote. Pi over 2. 2 left. 1, 2. Negative pi over 2. Alright. So now that's step 2 is the vertical asymptotes. It's done. Step 3 is the chopping time. Okay, so left vertical asymptote, negative pi over 2 times 1/2 gives me negative pi over 4. Right vertical asymptote, pi over 2 times 1/2 gives us pi over 4. Alright, I'm going to add these points in between my origin and my asymptotes. Negative pi over 4, pi over 4. Okay, so this is where we would apply the slope, but we have a change, okay? So that k, so k means we shift up 2. All right, so from my origin right here, I'm gonna come up 2 units. I'm gonna plot a new point, orange. Okay, and that's my new point, shifted up. Okay, so now I can erase that. So I'm gonna go back to applying my slope. So up one, right one, down one, left one. Connect in a nice smooth curve. And that is your tangent graph. So to compare it to the original, here's the original. As you can see, nothing's changed except for it's just shifted up 2 units. And we'll do the same thing if there is something in the middle, usually like a pi, so you just have to add that number to your asymptotes. Alright, I'll post a problem probably if you struggle with it on the assignment, so I'll post some help in a little bit. Alright, so this is graphing the tangent function. And your assignment is below. 3.3 assignment, numbers 1 through 8. Good luck. Message me if you